We know that charged objects attract or repel each other, but with how much force? The force depends on the amount of charge on the two objects and the distance r between them. The relationship is called Coulomb's law, where we see that F equals 1 over 4 pi E naught, which is a constant, times charge 1 times charge 2 over r squared. If you've done mechanics, you will see at once the parallel between this and the equation for the force of gravity between any two masses. For the electrostatic force, the constant epsilon 0 is called the electrical permittivity constant for free space, which means vacuum or any gas. We often combine it with the 4 pi to get the electrostatic constant K. Now let's look at a sample calculation. I'm going to work out the approximate size of the force of repulsion between two protons that are in the same nucleus. Now we'll assume that the distance between them is about 1 by 10 to the minus 14 meters. And of course the charge on each one is just plus the charge on an electron, 1.602 by 10 to the minus 19 coulombs. Now, the force is going to be 1 over 4 pi E naught, Q1, Q2, which in this case is just Q squared, over R squared. So, that first term is about 8.99 by 10 to the 9 by 1.602 by 10 to the minus 19 squared over 1 by 10 to the minus 14 squared. When I plug that in, it turns out to be about 2.3 newtons of repulsive force between those protons. So what might be holding them together? Could it possibly be gravity? Now, the force of gravity is similar in form to the electrostatic force equation, but we have the gravitational constant times the mass of a proton squared over r squared. Now, the mass of a proton is about 1.67 by 10 to the minus 27 kilos. So this force will be 6.67 by 10 to the minus 11 times 1.67 by 10 to the minus 27 squared over my 10 to the minus 14 squared, and that turns out to be about 1.9 by 10 to the minus 36 newtons, which is an attractive force, but as you can see, not nearly large enough to hold those protons together. There must be a larger force acting.